Good evening all. Am I audible? Rohit, good evening. Aruna, good evening. Bhavani, good evening. Bonala, Ramya, good evening. Aishwarya, good evening. Am I audible? Is my voice clear? Are you able to hear me? Pavitra, good evening. Yeah, thank you for your response. Yeah, thank you all. Yeah, Bob, James, good evening. Ujjaini, good evening. Ivan Shankar, good evening. Raghava, good evening. Manjusha, good evening. Yeah. Thank you all for your response. So this is Indra from Pantech e-learning. So today is our second day of this 21 days masterclass on IoT, right? Yeah. So today we are going to talk about another introduction part, which is ESP8266 NodeMCU, which is nothing but just a microcontroller which we are going to use for this masterclass, right? So let me start, right? Okay. So first, what is an ESP8266 NodeMCU? That we have to know, right? So see, ESP8266, which is nothing but just a microcontroller which is low cost Wi-Fi chip which is actually developed by Espressif Systems. It can be used as a standalone device, or it can be used as a UART to Wi-Fi adapter to allow other microcontroller to connect to a Wi-Fi network. Those who have already have a knowledge about Arduino, I think you may get to know that Arduino doesn't have any built-in Wi-Fi. If you want to connect it to the Wi-Fi, in the sense you have to externally connect it. You can't connect it with the internal Wi-Fi because it doesn't have any. So you can call ESP8266 as the advanced of Arduino UNO. Not like Arduino UNO, but in ESP8266 you have so many things which is already present inside. I mean inbuilt. You can have Wi-Fi in inbuilt. Okay, so let's talk about briefly in later slides. Now let me just give you a short introduction. Okay, for example, you can connect ESP8266 to an Arduino to add Wi-Fi capabilities to your Arduino board. Okay, I hope you understood this. The most practical application is using it as a standalone device. This is advisable. Okay, so with the ESP8266 you can control inputs and outputs as you would do with an Arduino, but with Wi-Fi capabilities. Okay, so this means that you can bring your projects to online. You can connect it with network, which is great for like home automation and IoT applications. Okay, so now let's see why is an ESP8266 NodeMCU is so popular. So this is what is an okay. The next slide. Okay, so why is ESP8266 is so popular? Because it is actually low cost. So you can get ESP8266 boards starting at I think rupees 500 or something, 500 to 700, something like that, depending on the model what you are getting. Okay, and coming to low power. So it only consumes very little power when compared with other microcontroller, and can even go in deep sleep mode to consume just less powers. Okay, and then Wi-Fi. So the ESP8266 can generate its own Wi-Fi network or connect to other Wi-Fi network to get access to the internet. Okay, so this means that the ESP8266 can access online services to make HTTP request or to save data to the cloud. For example, it can also act as a web server so that you can access it using a web browser, and you can able to control and monitor your boards remotely. Okay. Contacted me, they sent me login, but it's showing wrong password. I'm unable to contact. Okay, so I noted down your query. I will pass this query to your to your coordinator, and they will respond you. Okay, genuine beatbox. Okay, fine. So I will pass this to the coordinator. They will follow you, right? So sorry for this. I will convey the message to them, right? Okay. And then compatible with the Arduino programming language. Those I have told you that those that are already familiar with the programming the Arduino board are happy to know that they can program the ESP8266 in the Arduino style. Those who don't have any knowledge on Arduino, it's okay, fine. Let's start study from the scratch, okay? And then compatible with MicroPython. So you can program the ESP8266 with MicroPython FimFab, which is a re-implementation of Python 3, which is targeted for microcontrollers and embedded system. I think yesterday some of you are asking about the programming language and all. Now this is the answer for that question, right? It can compatible with Arduino programming language and as well as MicroPython. You can go whatever you want, but here we are going to programming this in Arduino programming language. It's nothing but C language, okay? Okay, now what can you do with an ESP8266? Here a short list of what you can do with ESP8266. What you can do? You can create a web server to control outputs. You can create a web server to display sensor readings. You can send HTTP request. You can control outputs. You can read inputs and you can set interrupts. You can do so many things. You can, data logging projects, communicate with third-party services. You can create your own web applications. You can send emails, notification, post tweets, etc. We will study all those stuffs in the future sessions, okay? Okay. So this is the ESP8266 12E Wi-Fi chip. Okay. So what is the processor? Extensor single core 32-bit L106. It will running at like 80 or 160 megahertz. Okay. And coming to the memory, it have 32 KB of instruction RAM, 32 KB instruction cache RAM, 80 KB user data RAM, and 16 KB ETS system data RAM. ETS is nothing but Erlang term storage, which is capable of storing large amount of data and offers constant time data access. Okay, and coming to the Wi-Fi range, this is the range, and it will have like 17 GPIO pins. It have SPI, serial peripheral interface bus. It have I2C. I2C is nothing but software implementation. Okay, and I2S is nothing but integrated inter-IC sound bus. So I2S interfaces with DMA. Sharing pins with GPIO. So I2C is used to connect to for general inter-IC communication, that is EEPROM or sensor, something like that. I2S is usually used for only for audio devices. So this is the difference between I2C and I2S, okay? And then UART on dedicated pins plus a transmit only UART can be enabled on GPIO 2. You can learn it in the pin description and until wait then, okay? Okay, and then you have 10-bit ADC. Successive approximation of ADC is nothing but analog to digital conversion, right? Okay, so now see this. In NodeMCU, you can go for two microcontroller. One is ESP8266, which is basic, and another one is ESP32. Okay, so this is the processor. In ESP8266, you have like extensor single core 32-bit L106. If you are a beginner in the sense, you can go for ESP8266. If you have already worked with Arduino or if you have already have a good knowledge on ESP8266 in the sense, you can go for ESP32. ESP32 is the advanced version of ESP8266. So both will work in the same manner with little bit difference, okay? You can go for the same programming, everything and all same, but you will face some little difference, okay? So this is a successor of ESP8266, which is nothing but ESP32. 32 combines Wi-Fi and Bluetooth and is dual core, okay? Yeah, you can share your mail ID here, okay? So don't share your personal number in the chat box. You can share your mail ID here. They will contact you, okay? Yeah. Now coming to Bluetooth. Bluetooth, ESP8266 doesn't have any inbuilt Bluetooth, but 32 have Bluetooth 4.2 and BLE. BLE is nothing but Bluetooth low energy. And coming to the frequency, in 8266 you will have like 80 megahertz, and 32 you will have like 160 megahertz. And there is no static RAM, flash and all, and ESP32 have all those steps. And coming to the GPIO, 8266 only have 17 pins, 32 will have like 34 pins. Okay, so pulse width modulation, 8266 have 8 channels, but 32 have 16 channels. It have 2 SPI, 1 I2C, 2 I2S and 2 UART. And coming to 32, it will have like 4 SPI, 2 I2C, 2 I2S and 2 UART. And coming to the resolution of ADC, 8266 only have 10 bit, but ESP32 you can have like up to 12 bit. And there is no inbuilt touch sensor or temperature sensor or Hall effect sensor in ESP8266, but you will have all those steps in 32. Price it will be differ, like you can get 240 rupees now. I don't know the actual price of ESP8266, maybe it can be increased, right? So this is the price amount of ESP8266 and 32. You can choose whatever you want. The programming part, connection part, everything and all same. There is a little bit difference in the both controller. You can get to know the difference in the table itself, right? Yeah. So again I am telling you this valuable information. You can convert this masterclass into internship. So let me tell you what are the benefits you will get in this internship, right? So in this internship you will get 30 days of live recording sessions. You can get access to all the records. You will get 8+ project source code. You can join the VIP community group. You can download all the presentations. You will get internship confirmation letter, and after that you will get internship certificate. So the actual amount of this internship is for 1,999, but there is a discount amount which is available for you, which is only for 799. So this is the registration link. Go for it and make your registration, and the last date to register is 5/6/2024. Make use of it. And these are the ads on project you will get in this internship, which are smart street light using LDR and IR sensor, monitoring soil moisturization using sensor, gas leakage detection using Arduino IoT cloud, an IoT based heartbeat monitoring system, and BME 280 sensor readings to the real-time database, web based remote serial monitor, sending email using SMTP, and telegram request to the sensor readings. And also there is a 3-in-1 bundle course is available for you. In the lineup you will get IoT, embedded system and Arduino. And the registration actual fees is 1,999, but there is a discount amount which is available for you, which is only for 999. So this is the registration link. Go and grab it, and the last day to register is 5/6/2024. So make use of it. And what are the benefits you will get in this bundle course? You will get 90 days of live session, 1 year validity, 20+ project source code, and you can get access to the VIP community group, and you can download all the presentations. You will get internship confirmation letter and internship certification. So let me tell you one thing. After finishing this 21 days of masterclass, if you want participation certificate, in the sense you have to pay for it, which is only 118. You have to pay for the participation certificate, and you can get the certificate, right? Himanshu, yesterday itself I told you you have to find it out and you have to come and tell me, right? So now you tell me, who is the father of IoT? I passed this question to you. You have to tell me the answer, right? So I will wait until the class ends. So you have to come with the answer. Who is the father of IoT? So those who know the answers, you can drop the answers in the chat box. But I am waiting for Himanshu's reply. So please don't spam the chat box. Go and find out the answer and come to me. Okay, so now let's talk about the ESP8266 versions. Okay, so there are actually several versions of ESP8266. ESP01, ESP12E are the most popular versions. Okay, So you will find a wide variety of development boards with ESP12E and ESP12F chips. So now see this. Kevin Ashton. Yes, that is the right answer. Now you know the answer, right? You don't have to copy paste all those time. You can tell one time and leave. Don't disturb the other students, please. Okay. So thank you for your response. Okay, now let's talk about, in previous slide we have only talked about the chip itself, right? So now we are going to talk about the development board. So see, this is the chip and this is the development board. Using bare chips or modules is not easy or practical. So for learning, for testing and prototyping, you will want to use ESP8266 NodeMCU development board. These are the development boards. So these comes with all the needed circuitry to apply power, to upload code and easy access to the GPIO. See, you can see the difference for the chip and the development board, right? So to connect to the sensors or actuators and antenna for the Wi-Fi signal and other useful features actually, right? See this. How to choose an ESP8266 development board. So if you are a beginner, you can get the doubt. How to choose? What is the board is best for my project? So see, there is a wide variety of ESP8266 board from different vendors. Okay. So while they all work in a similar way, some board may be more suitable for some project than others. So when looking for an ESP8266 board, I mean the development board, there are several aspects you need to consider. So the first one is USB to UART interface and voltage regulator circuit. So most full feature development boards have these two features. So this is important to easily connect the ESP8266 to a computer to upload code and apply power. Okay. The second one is boot and reset or enable button. So these are the pin which put the board in flashing mode or reset, I mean restart the board. And then pin configuration and the number of pins. To properly use the ESP8266 in your project, you need to have access to the board pinout, like a map that shows which pin corresponds to which GPIO and its features and all, right? So additionally, some boards have more accessible GPIOs than other. So that's a factor you should consider depending on your project features. Okay. And then the size. So there is a wide variety of ESP8266 board with different sizes. So some boards benefit from a small form factor which might be very practical depending on your project features. Usually smaller board have a smaller number of available GPIO like ESP1. I have already shown you that, right? So like this. So you have to choose the board which is purely depending upon your project you are going to do, right? So the coordinator will send you the link to apply all those steps, okay? So after finishing the masterclass or the last day of the masterclass, they will send you the link. You can go through it and you can go and pay for it, right? Okay, so last one is antenna connector. See, most boards comes with an onboard antenna for the Wi-Fi signal. So some boards come with an antenna connector to optionally connect an external antenna. Okay, so adding an external antenna, nothing, which increases your Wi-Fi range. Okay, see, ESP8266 12E NodeMCU kit. So this is the controller we are going to use in this masterclass. The name is ESP8266 12E NodeMCU. Okay, so see, this NodeMCU kit is one of the most used ESP8266 development board. It features 4 MB of flash memory. You can access to 17 GPIO pins and 1 ADC pin with 10-bit resolution. Okay, so in addition, the board has built-in voltage regulator and you can power up the module using the mini USB socket or the VIN pin. Okay, so uploading code to the board is as easiest uploading code to the Arduino. You just need to plug the USB cable to this microcontroller and your laptop or PC, whatever you are using. Okay, so there is no need for a programmer or no need for a extra circuitry because it has a built-in USB to serial converter. Okay, so there is no need for a programmer or extra circuitry, and most boards comes with USB to UART chips. Okay, so it comes with an onboard antenna for Wi-Fi signal and comes with reset and flash button to reset the board and put the board into flashing mode. And you can also see there is a blue LED internally connected to the GPIO pin 2, which is very practical for debugging. Okay, so this is the SPI8266 board model we use more often in our Wi-Fi and IoT projects. So it is very versatile and it's great for beginners. So if this is your first time with the ESP8266 in the sense, this is the model I recommend. ESP8266 12E NodeMCU kit. Okay. So other popular ESP8266 development boards. So other popular boards are, one is ESP01 and ESP8266 VMOS D1 Mini. While I don't recommend the ESP01 for beginners, ESP8266 VMOS, D1 Mini can be the good choice. Because now let's talk about the ESP01. So this is a super small and fits in any enclosure. So it's perfect for like finished projects. However, it is very limited in the number of accessible GPIO you can able to get to know. That is only 8 pins, right? And doesn't have built-in voltage regulator. So you need to use a 3-volt power source, or you can add a voltage regulator to drop the input voltage to 3 volt. So additionally, it doesn't come with the USB to serial converter. You can be able to see the picture itself, which means you need a programmer or you need a specific programmer board to upload the code. So you will face some difficulties if you are a beginner, right? Now VMOS D1 Mini. See, VMOS D1 Mini offers 4 MB flash memory and you will get like 11 GPIOs and 1 ADC pin in a minimal and small setup. Okay, so the community has developed a wide variety of shields for the D1 Mini board, which allows you to build simple and small setup with almost no wiring required. Okay, so you just need to stack this shield to connect multiple peripherals. So it comes with the built-in voltage regulator and USB to UART converter, which makes it easy to upload a code. For these reasons, this might also be a good choice for beginners. So there are many other versions of different ESP8266 board. So most boards works in a similar way. Just make sure they are suitable for your project requirement or not. Okay. Okay, now let's talk about the difference between ESP01 12E NodeMCU and VMOS D1 Mini. Okay, So here you can see the main difference between ESP01, ESP8266 NodeMCU and the VMOS D1 Mini. Okay. So please wait until there is actually few more slides left. I will explain all those pin, everything and all in that slide. Okay. So I will tell all the purpose of the purpose of all pins, why we are using everything. Okay. So please wait until then, right? Okay. We didn't go for the pin description and all. So please wait until then, I will tell you. Okay. So coming to the GPIOs, in ESP01 you will have like 4 and ESP12, 11. I already told you that 17, but 11 pins we are going to use. The remaining pins will go under like voltage pin, ground pin, something like that. Okay. So same for VMOS D1 Mini, 11 pin. And ADC, all the model will have one ADC, and these are the flash memory and breadboard friendly. These two are breadboard friendly. This is not, because you already know that, you already saw the ESP01 pin, like. So USB serial converter, it doesn't have like any. So these two have the USB to serial converter, and this is the size. Okay, so these are the difference between ESP01, 12E NodeMCU and VMOS D1 Mini. Okay, so now let's talk about the main thing, which is ESP8266 chip pin out. So see, a pin out is like a map that shows which pin corresponds to which GPIO. Pin number is different, GPIO is different. Okay, so this way you should know which GPIO to use. If you need to use SPI or if you need to use I2C, ADC or other instances, you have to know that which GPIO corresponds to which pin. So the ESP8266 chips comes with 17 GPIO pins. So not all GPIOs are exposed in all ESP8266 development board. So some GPIOs are not recommended to use and others have very specific function. So note that. Are you able to hear me now? Are you able to hear me? Is this audible? Am I audible? Are you able to hear me? Is my voice is clear? Yeah, thank you. Okay. So note that not all GPIOs are accessible in all development board. Okay, so but each specific GPIO work in the same way regardless of the development board you are using. Okay, so at the moment there are a wide variety of development board with the ESP8266 chip that differ in the number of accessible GPIOs, the size or form factor, etc. So thank you all for your response. Yeah. So now see this. Okay. So now let's talk about the pin and peripherals and all. Okay. So we will have 17 GPIOs. You will have SPI. You will have I2C, you will have I2S, you can have UART 10-bit ADC in this single chip. Okay, here you can able to see. So these are the pins which correspond to SPI, MOSI, MISO and all, and UART pin is noted down as TX and RX. Where is the TX and RX? Here. Receiver and transmitter pin is for UART, and data pin and clock pin is for I2C pin. So when you are getting to learn about the SPI, I2C and all, you can get to know why we are using that and what is the purpose of that. Okay, so we will talk about this stuffs and all in future sessions. There is a separate session for communication protocol. In that session you will get to know what is SPI, what is I2C, why we are using, why we are talking about that, everything. Okay, so now let's just talk about the introduction part only. Okay. So again I am telling you this is the right time to switch your masterclass into internship. In this internship you will have 30 days of live session, 90 days of access to records. You can get 8+ project source code. You can join to the VIP community group and you can download all the presentations. You will get internship confirmation letter and you can get your internship certification. And there is a discount amount which is available for you, which is only for 799. So this is the registration link. Go and grab for the link and make a registration. So the last date to register is 5/6/2024. Make use of this chance. And these are the add-on projects you will get in this internship, which are smart street light using LDR and IR sensor, monitoring soil moisturization using ASK sensor, gas leakage detection using Arduino IoT cloud, IoT based heartbeat monitoring system, BME 280 sensor readings to the real-time database, web-based remote serial monitor, sending email using SMTP, telegram request to the ESP8266 sensor readings. And also there is a 3-in-1 bundle course is available for you. In the lineup you will get IoT, embedded systems and Arduino. So the actual amount of this bundle course is for 1,999, but there is a discount amount which is available for you, which is only for 999. So this is the registration link. Make your registration, and the last date to register is 5/6/2024. So these are the benefits you will get in this 3-in-1 bundle course, which is 90 days of live recording sessions, 1 year validity, 20 plus project source code. You can join the VIP community group. You can download all the presentations. You will get internship confirmation letter and you will get internship certification. Okay. So now, what is the best pins to use? So one important thing to notice about ESP8266 is that the GPIO number doesn't match the label on the board silk screen. For example, see, D0 corresponds to the GPIO pin 16, not 0th GPIO. And D1 corresponds to GPIO 5. So this is the pin number, this is the GPIO number. Pin number is different, GPIO number is different. So D0 is corresponds to 16th GPIO pin and D1 is corresponds to GPIO 5. So this table shows the correspondence between the labels on the silk screen and the GPIO number, as well as what pins are the best pins to use in your project and which one you need to be cautious, everything under. Okay. So the pin highlighted in green are okay to use. The one highlighted in yellow, sorry, instead of giving 7th month, I gave 6th month. Sorry for this. Not 5, 6, 5, 7. I mean July month, 5th date. Okay. So please, sorry for this. And thanks to notify me. Instead of 7, I mistakenly put 6. So the last date to register is 5/7/2024, not 6. Okay. So the highlighted pin in yellow are okay to use, but you need to pay attention for that pin. Okay. So because they may have unexpected behavior mainly at booting. So the pins highlighted in red are not recommended to use as input and output. Okay. Okay. So first let me talk about GPIOs connected to the flash pin. So see, GPIO 6th pin and GPIO 11th pin are usually connected to the flash chip in ESP8266 board. So these pins are not recommended to use. Okay, and then what are the pins you can use during booting? Okay, so the ESP8266 can be prevented from booting if some pins are pulled low or pulled high. Okay, so for that, pins are high at boot, which is you can tell that like high at boot is D0, I mean GPIO 16th pin. So boot failure if that pin is pulled low. Okay, you can tell it as GPIO 0, and pin is high on boot, you can tell it as GPIO 2, and high at boot GPIO 3 and GPIO 1. Okay, and coming to analog pins, there is a thing called analog pin. So the ESP8266 only supports analog reading in one GPIO. So that GPIO is called ADC and it is usually marked on the silk screen as A0. So the maximum input voltage of the ADC 0 pin is 0 to 1 volt. If you are using bare chip, I am talking about bare chip, not a development board. If you are using a bare chip, the maximum input voltage of ADC is 0 to 1 volt. If you are using a development board like 12E NodeMCU kit in the sense, the voltage input range is 0 to 3.3 volt. Because these boards contain an internal voltage divider, and you will have onboard LED and reset pin. So when the reset pin is pulled to low in the sense, the ESP8266 reset. So this is the same as pressing on the onboard reset pin. Okay. So if we apply for internship, we will get the kits. No, you can't get the kit. You will only have the programming part. I mean, you will get the source code. You will get the recorded sessions. You will get the PPTs and all. So if you want a kit in the sense, you have to pay separately for that. We can't provide the kit for that amount. It is quite expensive actually. So if you apply for internship, you only get PPTs, recorded videos and the source code, all downloadables, but you can't get kit. If you want kit in the sense, you have to pay for it separately, right? Okay. And coming to I2C pins, SPI pins and all, see, there is a thing called SPI, this is I2C. See, the ESP8266, note this, I am telling you this, please note this, ESP8266 doesn't have hardware I2C pin, but it can be implemented in software. So you can use any GPIOs as I2C. Usually the following GPIOs are used as I2C pin, which is GPIO 5 and 4. Okay, and coming to SPI, so GPIO 12, GPIO 14, 13, 15, these pins are for SPI pins. MOSI pin, meso pin, clock pin and chip select pins and all. Okay. And coming to pin, pulse width modulation pin, ESP8266 allow pulse width modulation in all input output pin. You can go for GPIO 0 to 15. So pulse width modulation signals on ESP8266 have, I already told that, 10-bit resolution. Okay. And coming to the interrupt pin, ESP8266 support interrupts in any GPIO except GPIO 16, because this pin is used to wake up the ESP8266 from deep sleep. Okay. And coming to the power pin, you will have like 3 volt power pin, ground pin and VIN pin. If you are not providing power through the ESP port in the sense, USB port in the sense, you can use these pins to power the board or to get power from other peripherals. If you are powering the board using USB port and all, I am telling you that, right? Okay. So now, how to program the ESP8266. So there are many different ways to program the ESP8266 using different programming languages. You can go for C language, MicroPython, LUA and others. So our preferred method is programming the ESP8266 using Arduino programming language. I already told you that I am going to use Arduino programming language with the IDE called Arduino IDE. For beginners, I recommend getting started with Arduino IDE. So to program your board, you need an IDE to write your own code. If you are just getting started with ESP8266 in the sense, start with Arduino IDE. So how to download Arduino IDE? So go for Google, you can download like Arduino IDE download and you will get the official site. Here is just software Arduino. And scroll down, you can go for the OS which you want. Here Windows 10, mine is Windows. And scroll down, just click just download and it will ask for your email ID and check out this box and just click just download. It will download to your desktop. Okay, that is a simple process. So after giving your mail and after you clicking on this box and just click just download, it will download it to your desktop. Just open it. Okay. So that is the simple process. You can download Arduino IDE and after downloading IDE, we have to, that is the Arduino IDE, right? So here we are going to use Arduino IDE, not ESP8266, not Arduino. So then only we can able to program the ESP8266 NodeMCU. Okay, so for that we need one thing. Let me tell you how to add those things. Let me open Arduino IDE here. See, here we are using Arduino IDE to program ESP8266. To use ESP8266 in Arduino IDE, you need to install one package. So let me tell you how to download that package, right? So for that you have to go for files, and after you downloading the Arduino IDE, your page will look like this. This is the sketch page, okay? And you have to go for file, preference, here additional board manager URL. So here you have to copy paste that URL that you are getting from your Google. So you can get it from, like, let me tell you that ESP8266 package link. So go for GitHub, scroll down, and here you will get, like, see, you can copy this link. So board manager link, you can copy this link and you can go for this file preference and paste the link and just click OK. Okay, and then you need to open the board manager. So this is the board manager, or you can go for tools, board, and board manager here. This is a simple way to open your board manager, right? So here search for ESP8266 and click enter. So here you will get, like, ESP8266 by ESP8266 community. Search for the latest version and install it. I have already installed this package. So please, first step is download Arduino IDE from its official website. Download according to your OS, right? So mine is Windows, so I have already downloaded it. After downloading, open your Arduino IDE. So go for Google and search the link like ESP8266 package link. Copy that link and paste the link in file. Go to preference, paste the link here, click OK, and then come to board manager. Search like ESP8266 and you will get like ESP8266 by ESP8266 community. Search for the latest version and install it. And after this, restart your Arduino IDE. Okay, after you restarting this, go for tools, board, and you will get like the package called ESP8266. So before installing it didn't have anything like this. I have Arduino, I have ESP32 and I have ESP8266 because I have already installed all those steps. So after installing, please go and check you have ESP8266 package like this. Okay, so here we are going to use the name like NodeMCU 1.0 ESP12E module. So when we are going to the programming part, I will tell you how to write program, how to select the board, everything and all. Okay, so now you are ready to start programming your ESP8266 using this Arduino IDE. You will have all example program here itself. You go for example, you will have like basic, digital, analog, communication, control, sensors, display. You have so many example program here. So in tomorrow's session, we can go for how to programming all those steps and how to select the board, how to write programming, how to upload the program in ESP8266 board, everything and all. Okay, so this is all about today's session. I hope you understood this. So let's catch up at tomorrow's class with another topic, right? So thank you all. Have a very great day.